Like I said, I only got halfway through it. Yeah.
So can you tell us your name and what you're doing and stuff like that? Okay.
Absolutely. My name is Michael Mall. I'm a software developer at a small company in Jenison, Michigan. Jenison is a suburb of Grand Rapids. Grand Rapids being over on the west side of the state, for those of you who are mostly familiar with this south. Snow country. It's been about the same amount of snow all the way across the state today. I've been a software developer for about 5 years. The other thing that I do is anything and everything I can as far as learning about computers and technology. I run a website called rosettacode.org. It's just a website for programmers, people interested in programming languages.
Sorry about that.
And sometime early last year, I started getting interested in IPv6. IPv6 has been, it's turned out to be actually very easy to implement server side. As far, if you, Apache supports it, and all of your basic tools are going to support it as far as servers are concerned. The big problem I ran into was Squid 2 doesn't support it, but Squid 3 does. So that's, it's a very simple, straightforward upgrade. I mean, your configuration files will still work. There's not a whole lot to say about me. I'd love to say I have an incredible number of bona fides. All I have is an incredible amount of drive to learn about things. But towards the topic. First off, I realize this is the a Linux users group. How many of you are actually using Linux at home? Okay, just wanted to see if I spotted any hands that weren't up. All right. How many of you are using Windows at home? Okay. How many of you are using Windows XP?
Well, at home or
I work at home, so I do. I guess.
Sure. Okay. In any environment, how many of you administer Windows XP?
Oh.
Okay. And including on your own personal workstation, like if you have your own Windows XP machine. What about Windows Vista? Sorry. What about Windows 7? Okay. Alright. And anybody using Macs? Nobody's going to jump on you.
The household has
no. Yeah, we'll
and I
be
use
way
it once in a while.
So
Okay.
some of the staff members have.
Sounds like a nice place to work.
That I have.
All right, so there are some differences between Linux and Windows on as far as IPv6. There's even more differences within different versions of Windows. If you're running Windows Vista or Windows 7, you're running what's probably the desktop operating system that's most currently capable of handling IPv6. Windows XP, it can, don't. They do have a beta version of IPv6 support that you can install using a command called netsh, and that will allow you to configure IPv6. But XP is end of life, and it's going out of support, and IPv6 is still changing a little bit, and you really are better off using Vista or Windows 7. Yes, I just said you're better off using Vista than XP. Deal with it.
Plus Microsoft Beta is alpha for anyone else.
Yes, I don't have to worry too much about that.
Plus Microsoft Beta is alpha for anybody else.
That's true. All right, so in Linux, IPv6 is actually very simple. Unless you're building your own kernel and you explicitly disabled IPv6 support, you've probably already got it. How many of you avoid using Network Manager? Okay. How many of you know what Network Manager is?
I'm talking about network management in Linux.
In Linux, yes. Okay. If you avoid using Network Manager, you're going to be mostly okay. If you're using Network Manager, you're still going to be mostly okay. There's still some bugs in terms of IPv6 support on Network Manager. I worked with the devs on that one a little bit a few months ago to get one of those quirks ironed out. It's getting better. Let's see. So I have a good idea of the software you guys are using. How many of you are familiar with the OSI network stack? better question. How
Barely
many of you aren't? Okay. The OSI network stack is basically abstracting away the different components of your network connection. You have, let's say all of you are probably connected to the Wi-Fi here. At least those of you who brought machines. You're probably familiar with the concept of Ethernet, and you've heard of IP, or you've at least heard of TCP/IP. The wireless network, specifically the radio waves, that's layer 1. That's a physical layer in the OSI network stack. The fact that you have something like an Ethernet frame, that's layer 2. On top of layer 2 goes your IP packets, the packets that say, hey, I want to talk to this machine, and it doesn't have to be on the same little network that I'm on. That's layer 3. On top of that goes layer 4, where you'll find TCP, UDP, TCP/v6, UDP/v6. Most of what we're going to be talking about is layer 2 and layer 3. We're really not going to need to touch that much on the differences between TCP between IPv4 and IPv6. But layer 2 and 3 are very interesting. In IPv6, every machine that you have, every network interface that you have, is going to have multiple IP addresses. You're going to have the IP address that corresponds to your layer 2. That corresponds to your local network. So, for example, if you're all plugged into the same Ethernet switch, you're all directly communicable using your link local IP address. On top of that, you would have an address for your global scope. Your global scope means that you can get to my server from wherever you are, or that I could get to your system if the firewalls didn't block me. Global scope is routable. Your link local scope is not. We usually use a whiteboard at this point.
You can use
I
that.
was just saying, do we have a whiteboard too?
I can go out in the warehouse and get a stand for you. Hang on. Very good.
There's one behind the thing there.
No, it's good.
Would you be comfortable maybe putting a laptop with a graphics software on it?
What's that?
A laptop with graphics software, maybe?
If my tablet with a stylus still works, probably. I'm better at drawing than using a graphics software. Mostly what I'm actually going to do is write in so small none of you can read it, I suspect. Yeah, I think perhaps plugging my laptop in will work a little bit better. But in IPv6, your IP addresses, they're the first 32 bits of your IP addresses are very meaningful. In fact, I should probably backtrack a little bit and talk about the one of the significant differences between IPv4 and IPv6. In IPv4, your addresses are all 32 bits long, 4 bytes, four ASCII characters. That's not a whole lot. That's only 4 billion addresses. And that's okay, I can do this here. Alright, in IPv6, addresses are 128 bits long. That's a much larger number of addresses. That's, it's said that that's enough addresses to, have an individual IP address for every grain of sand on the planet. We'll probably run out long after I'm dead. In IPv6, you have so many addresses that they actually gave the first 32 bits of each address a special meaning. If you have an address that's linked local, that address is going to begin with FE.
And Parker just died.
I think I'm going to wait for the laptop's going to come up there.
Do you want me to go get you another marker? Or
No, I'm all right. I don't use GNOME, KDE, or LXDE, or any of your normal desktop managers. My apologies in advance.
As long as it works for you, who cares?
Yeah.
long as we don't have
Whatever works.
Goldberg versus Katie Eagle, that'll be fine.
No. LXDE wins.
I do like LXDE for if you need something that's familiar to a Windows XP user. All of your Windows XP keyboard shortcuts port directly over. So, all right, so.
Do you want to sit down?
Nah, easier for people to see me if I'm standing. That's gonna be close enough. I don't know LibreOffice that well. Alright, so. Can everybody see that? Or how many people can see that versus how many people can't?
Camera ain't gonna pick it up, but it's not a big deal. Sorry. We'll post the note. You'll send me these notes, right? And I can post it on the website.
Yep. And anything that's missing, just send me questions. Oh, that'll be good. FE80. One thing that's probably noticed is that's hexadecimal. All IPv6 addresses are represented in hex rather than decimal. That's important because otherwise you'd have several very large numbers. Yeah.
Aren't they still just 2 digits, so don't we need a colon between the E and the 8?
No, actually, each section of an IPv6 address consists of 32 bits. And what you might notice here is I actually have 2 colons there. What that means is that the rest of it's filled with zeros. The addresses are so long that somebody decided, I don't want to type that many zeros in. An address that begins with FE80, that's a link local. That's valid on your local network. An address that begins, for example, with 2002, that's something called a 6-to-4 address. A 6-to-4 address is one way that you can get on the IPv6 network if you have a public IPv4 address. If something begins with almost everything else, but for an example, we'll use 2001. That's one of many 32-bit prefixes for global IPv6 address space.
I'm sorry, say that again?
One of many prefixes that's valid for the global IPv6 address space.
I have a question. Can we go back to FE80 for a second?
Yeah, sure.
So FE80 is private address space, basically. So, but that would be like here. I'm on the 10 dot inside the building here. So that would be equivalent to that kind of a thing.
Not exactly. What you're thinking, the closest equivalent to that would be something called the UFA, which is kind of like a site local address space. Those begin with FE, and then couple numbers which I don't recall. I don't know how much of that you can read. I'm used to reading very small text. I don't think I have to get it. I don't think I have a better terminal installed at the moment either. But
No, I don't think anybody can read that.
okay, well.
Is there a way of just making it larger somehow?
Using Xterm, I have to modify the X resources, which I don't recall if X resources. What those resources? How about X details? Okay. Where'd you go?
It didn't like it.
I didn't like something. I can see that one.
Yeah, but it's above. It's bigger than your screen.
That's strange. There. That's what I did wrong. Okay, can you read that?
Yes.
Oh, yes.
Alright. Okay. So, at the you, that's my loopback address. All of your machines have a loopback address. That's so programs on your computer can communicate with other programs on your computer without ever hitting most of the network stack, without going over your local network.
So in IPv6 it's all zeros.
Yep, in IPv6 your your loopback address is actually, if you can see where it says inet6 there, it's ::1/128. How many of you are not familiar with CIDR notation?
Oh,
Okay.
a little bit.
Have any of you ever heard of a /24?
Yeah.
Okay. It's the same thing. What CIDR notation corresponds to is the fact that you have this many bits of address space, and you decide, okay, your upstream ISP is responsible for this part, and you're responsible for that part over there. And I probably should have flipped that around because that was more me reading left to right. But so, for example, here you see where it says inet 127.0.0.1/8.
Matt, can you close this down or move it so that...
No.
No, okay, all right, just thought it. All right, fine. All right, yep, okay.
Okay. Actually, why don't I just go ahead and select it here. Here's your localhost IPv4 address. 127.0.0.1. That /8 means that the first 8 bits of that, specifically the 127, those are fixed. And the rest of it, the remaining 24 bits, those could be whatever. It's thinking of itself as having about 24 bits of address space internally to work with.
Wow.
With IPv6, your addresses are all 128 bits long. So if you have a /128, that means that you're actually not responsible for any of it. It's very much fixed, since the 128 corresponds to the entire length of the address. If I scroll down a little bit.
So where it says that, so like where it says inet6 1/128, that means that is fixed. It's all zeros except for the 1 at the end, and that's it. That's the whole address. There's nothing else involved in it.
Right.
Okay.
And you can see that there's the double colon preceding the 1, which means it's 127 zeros, then a 1, and that's your IP address. And GRE, I'm not actually using that. SIT, I'm not using that. E0, my wired Ethernet connection. It's not actually attached to anything, but it still has an IPv6 address, if I can find it.
Isn't that like after?
Yeah, that's the MAC address.
Oh.
Yeah, that's actually your MAC address listed right there. That has a link scope. You're not seeing it.
What's link tunnel mean?
Link tunnel? That's... Oh, I know what's going on. What's wrong here? I didn't attach the wireless network yet. Oh.
That'll make a
There's your problem.
difference.
Yeah, that'll make a
No
little bit of
carrier.
difference. Okay. Okay. And let's actually look specifically at the wireless network.
Does ipconf not show the same things you're trying to look at? Or?
Ifconfig will show it the same stuff but in a different format.
Oh, okay.
Okay, well I can see it here at least. You can see interface 6, WLAN 0. Let's see, there's my IPv4 address on the local network. 10.0.3.104. Remember what I was talking about CIDR notation? There's a /16 at the end of that. And what that means is anything after that 10.0 number, so I'm .3.104, but if any of those other numbers were to be different for anybody else in the same network, I could talk to them directly without going through a router.
So it's a class B.
Yeah. CIDR stands for classless internet, something I can't remember anymore. But what it comes down to is, class A, class B, class C, those were great back when you could, conveniently divide things in terms of 8 bits or 16 bits or 24 bits. On my home network, I've got my wired and my wireless network divided into 2 different /27s. It doesn't quite evenly fall into a class-based thing. I mean, just because I'm sharing the RFC19 address space with a few other people, I actually have set myself up in a specific /24 so that I don't end up conflicting with any of them. And dividing that internally for my own purposes. But yes, the /16 means that there's about 65,000 IP addresses that I could talk to without bouncing off the school's router. Now here we have, okay, WLAN 0, iNet 6, so that's an IPv6 address. FE80 means it's a link local address. Also at the end of the line, you see it wraps, it comes back down to the word link. That means that it's telling me that, hey, this is a link local, this is a link scoped address. Here you see 2 colons, means it's going to fill it with as many zeros as it can.
Or as it needs to.
As it needs to. And over here, that's a number that's derived from my MAC address. In order to avoid having to talk to a DHCP server or anything, or any additional external configuration tool, IPv6 uses your system's MAC address very frequently. It's going to come in really cool when you find out that setting up IPv6 on a network is incredibly easy once you actually have that.
So you're saying with IPv6 there is no more DHCP server handing out addresses?
There doesn't need to be. There can be if you want it. And in fact,
I don't know, as a network administrator I would feel uncomfortable not handing out the addresses. You know what I'm saying?
I understand. Like I said, there can be if you want it. And one of the biggest uses of DHCP is to be able to push configuration information, like where are the DNS servers?
Yeah, and DNS servers and static. How do you assign a static address if you're not pushing out the addresses?
The addresses are static by default because remember your MAC address isn't going to change.
Right.
So basically, you're giving a lifetime address to a device.
Yeah. In fact, you're giving
Be it a telephone, a network card. I'll give you a curious situation.
Mm-hmm.
I have a network card.
Okay.
I take it off the computer A and put it in the computer B.
Yep.
Does it keep that address?
Computer B has the address that was previously associated with computer A.
It only has
So it
half
goes
the
with the
address.
network
So,
It goes to your MAC
hardware
address.
rather than the CPU.
okay.
Right.
Now
Okay.
for internal resources, if I were using IPv6 here,
Mhm.
okay, part of our structure here is we rent some space out to somebody else. Okay. They recently installed a VPN device and I had to point one of my external IP addresses to that VPN device.
Okay.
How do I do that in IPv6?
Well, in IPv6, what you would do is you would probably give them a prefix. Let's say that are you given a network range from your ISP, or did you go to Aaron and get it?
No, I have 5 addresses from my ISP.
Okay. So what you would probably do is if your ISP offered IPv6, or if you went through a tunnel provider like Hurricane Electric, you would get a /48 or maybe a /56, which is a lot of IP addresses.
Right.
And what you would do is you would actually take, let's say you got a /48 and you wanted to give them their own /56. You would say, okay, show me give me the internal address of your router, and
The
you
MAC
guys can
address.
have yeah, it would be probably the link local address. It's up to you how you do it. Once their machine has once their machine has...
Because the way I did it here with the IPv4 is I assigned them a static address, and then I pointed the gateway and said, this external address maps to this internal address.
Okay. Well, what would happen is you would know their internal IPv6 address, whether that's a link local address or a global scope address, which there's a little bit of a chicken and egg problem that's fairly easy to resolve. But if you know their address, what they do is their machine becomes its own router. If you have a /48 that's globally routable, you can divide that up into as many sections as you want and give that to somebody else, and they can have it operating on their own router. So your ISP will give you, a large amount of space, and you would say, go ahead and use this. I'm going to use G to represent your section of the address, and V for theirs, and I for the ISP. So you've got 128 bits. And the ISP is going to control this much of it. And otherwise, the rest of this is yours. And you can say, well, they come in. ISP still controls this much of it. And you're going to give that much of it to them.
And I'm going to retain the G part.
Right. Now, the thing is, this really extends more like this. And let's say you have, somebody else, or you have a computer lab where you want, them to have their own range of addresses, where they can, go do whatever they want, and you don't have to worry so much about them infecting this network. So this is your experimental lab. So let's say you gave them a /56. You gave your experimental lab a /56. You can do that because your /56 just represents a different chunk out of your larger address space. And it's one of the really, really nice things about IPv6.
So basically, DHCP is history.
No, you can still use DHCP if you want to, and DHCP is very much advocated by enterprise users, specifically because you can provide more configuration information. You don't need to.
Because you still have to. I still have to push DNS. How do you? You still have to, right?
Mm-hmm.
Even though it's IPv6 now, I still have to push the DNS servers.
Yep.
Yeah,
And
everyone
all
still
that.
needs.
So I would still need DHCP.
And, yep, and there's a difference between DHCP and DHCPv6. Not a whole lot of difference, but and your configuration options if you're using are you using ISC's DHCP server? What are you using to handle?
It's a Linux box, whatever. Just the DHCPD.
Okay, that's probably by ISC. The IPv6 version of their DHCP server configured essentially the same way. Now, there is a difference in how you get to the DHCP server in IPv6 as opposed to IPv4. In IPv4, you plug a machine into the network and it says, hey, yeah, I need an IP address.
Anybody? Anybody?
Wireless network with a lot of loss. Somebody says, hey there, what? I can't hear you. So, in IPv6, you plug a machine into a network and it doesn't do anything. Instead, what happens is your router broadcasts something called router announcements. Your router announcement is going to say, well, in a very basic configuration that doesn't include DHCP6, your router announcement is going to say, yeah, I'm your local neighborhood router. I control, or rather, you can use any of this amount of address space, and here's your prefix. And the prefix being either what the ISP gave you or whatever you decided to subdivide to that particular area of the network. And every machine that hears that has the option of saying, okay, well, here's my MAC address. There's the prefix. Prefix, MAC address, zeros. Good, I've got my IP address. It's incredibly easy.
Now you could even use that for security by, say, turning off the broadcast or the advertisement as your router. Continue routing, but not let anybody else know on the network after that point. Would that be correct?
To an extent, there's a lot of different and interesting ways that security can come into question in an IPv6 network. But for example, I use programmer.com for my VPS. I run a server, and that's that's in their data center. Now, they give me native IPv6,
Right.
but they're not pushing router advertisements. They actually they didn't tell me which address to use. Instead, there's an address that you can ping that's a multicast address, and anything that is a router will respond, which actually can be really interesting. But
So
yeah.
you would have to set, if you were in that type of a situation where your router wasn't going, woohoo, then each machine would have to be set up that once it acquired a network connection, it would send a ping on a multicast band.
Normally you would use router announcements if all of the machines in question were not pre-configured or static.
Right.
Like for example, in the server's case, those machines don't need to ask what the
Right, because when they come up, they know what they're going to use.
Right. And
The same way you configure a static address on a card now.
Sure. Yeah. Now you wanted to use DHCP. What you would do is in the configuration for RADVD. You have that's the tool that's available on most Linux distributions to send the router announcements. You would say, we're going to use some enhanced configuration, and they're going to go to that address to talk to a DHCP server. And what that's mostly going to do is say, all of this information, well, you don't get that much from me, but hey, I am the router, and you need to talk to that guy to get your address and any additional configuration. Router announcements are spec'd to support pushing information like DNS. Windows doesn't support that yet, and neither does Network Manager or any of the Linux systems yet.
So the router announcement can say, hey, I'm the router, but go here to get your address.
Right, just like in DHCP, you're able to have your DHCP server say, yeah, I'm a DHCP server, but you want to talk to that one over there.
To get out of the building.
Right. Like DHCP proxies, things of that nature.
I was thinking gateway, but...
Well, that, yes. Completely different.
Yeah.
Yeah. And I'll get back to you because I cut you off a moment ago, but go ahead.
Are there well-known addresses for domain name servers and that sort of resource on the local links?
Well-known addresses. Well, here's a couple of them, and I'll probably like that. I'll demonstrate one of them just because it's that fun. Let's see. Ping6 fe : I'm trying to remember how to do this. It's like all 3 days, and for some reason I'm forgetting now. That's not good. Did I disconnect from Windows Network? No, I did not. No, honestly, not certain what's going on there. Not going to worry about it right now. But there are multicast addresses in IPv6 for where you can ping an address, or rather, the address represents all of the machines on the local network. So you can often, if a machine is configured to respond to ping, you can find out how many machines are on the network. And it's a very easy way to scan for machines that you didn't intend to be there. As far as well-known addresses for DNS, no. The root domain servers are IPv6 enabled. Your the servers for com, net, and org are IPv6 enabled. Some of the TLDs are not yet IPv6 enabled, which is frustrating. There is something called IPv6 glue, which is important, and that's what the ComNet and org are already configured to be able to do. If you go through Hurricane Electric's IPv6 certification, once you get to the final stage of that, it actually touches on that some, the issue of IPv6 glue and being able to have DNS operate ideally, optimally on IPv6. You had a question earlier, and I was still responding to him, and I forgot to get back to you.
You answered it already.
Okay. Let's see. One of the things that's interesting and different between IPv4 and IPv6, how many of you know what ARP is? Okay, how many of you do not know what ARP is? Okay, for those who don't know what ARP is, ARP is when you have a machine on your local IPv4 network, and it wants to talk to another machine on your local IPv4 network. And the problem is, it needs to actually send the message directly. It needs to build a packet that actually operates on your Ethernet, well, at the Ethernet layer instead of just on the IP layer. It needs to know the MAC address of the target machine. And so it will say, hey everybody, who has 192.168.0.0.1? Anybody? And ideally, the person who has that address will say, yo, that's me. And at that point, both machines will know the MAC address of the other machine, and they'll be able to they'll be able to use Ethernet to address packets back and forth. IPv6 doesn't use ARP. IPv6 uses something called neighbor discovery. As it turns out, Ethernet supports multicast at the Ethernet layer. And neighbor discovery takes advantage of Ethernet multicast so that it doesn't bang all 48 ports of your switch in order to find one individual. And the resolution of Ethernet multicast means that it will be able to typically only hit about 1/16 of the nodes in your network when it's trying to find who it wants to talk to. So what that'll do is, for very large networks, that'll reduce your load. At least when talking to an IP address it hasn't talked to before. Let's see. We have DNS. DNS is a little bit different. How many of you know all that much about DNS?
Where do you define know all that?
Okay. How many of you know what an A record is? How many of you do not know what an A record is? Okay. In DNS, DNS is a very large database, and for any given domain name, you'll have several records. You can have an A record, which corresponds to an IPv4 address. So if you want to know what the IPv4 address of Google.com is, you ask your DNS server, okay, what is the A record for Google.com? If you want to know what the domain associated with a particular IPv4 address is, you look up the PTR record, the pointer record. If you want to know where the mail server is for a given domain, you look up the MX record. The biggest difference between IPv4 and IPv6 as far as DNS is concerned is in IPv6 you use what's called a quad A record. That's 4 A's instead of a single A. It's not 4 A records, it's just a record that has named that consists of 4 A's. A quad A record has just the global scope. Well, generally speaking, it should be the global scope IPv6 address. So if you want to know the IPv6 address of Google.com, you'd ask your DNS server for the quad A record of Google.com. This is pretty straightforward. Pointer records are used pretty much the same in both IPv4 and IPv6. In IPv6, in both cases, you have your least significant digit first, and you work your way towards your most significant digit. In IPv4, each digit is, in IPv4 you have a decimal value of 0 to 255. And that'd be your decimal value, dot your decimal value, dot your decimal value, dot your decimal value. In IPv6, you work your way back, using in hexadecimal, using one character at a time. They're much longer records. And no, you can't use the nice little double colon shortcut. It's nice to have those handled automatically. That's the big difference between IPv4 and IPv6 on DNS. Let's see. How many of you have played with IPv6 already? I do know that some.
I got as far, in Hurricane Electric's thing, I got as far as when you had to then have them assign you a block of addresses. So basically the first part.
Okay. There's a. I don't know how many of you have asked do you know if your ISPs offer IPv6 yet?
Most still don't, which is real
Most
annoying.
don't, some do.
Well, so which ones in the area are likely to, is
Your
AT&T?
area or mine?
Pardon?
And even in my area, Comcast is already rolling out IPv6 in Michigan. AT&T not quite as quickly. I don't know why. Okay, is that a DSL provider? Or
Cable.
Wide, was it wide open?
Oh, they're providing everything now too, cable TV and internet. So.
Well, you'll need to ask them. I'm not familiar with them. Ask them if they support IPv6. If you can't get native IPv6 support from your upstream, there are several ways that you can still get IPv6 support. Some work better than others. But as far as the current set of ISPs that are offering IPv6, like I said, Comcast is beginning to roll it out in Michigan. AT&T is working. They like to say they're the front runner, but the funny thing is they're only starting in spring, really, and then only the government customers, because government customers are mandated to support IPv4 and IPv6 natively.
Good.
Very soon. There's not a whole lot of options that I'm aware of. Yeah.
So I'm currently paying AT&T for IPv4 addresses. Is there other options? Do I want to continue to pay that fee?
Are you using their Uverse or are you using
Yes.
Okay.
You guys standing?
Static, right.
You're paying them for static IPs?
Yep.
One of the problems and the thing that I really don't like about AT&T Uverse is that you're really stuck with AT&T. If you want the what's called VDSL, which is like the next level up above ADSL, which is what you've got. You have VDSL if you're using Uverse. AT&T uses 802.1x authentication in order to guarantee that you're using their equipment with their internet connection. And as far as I know, they are not reselling VDSL to anybody else. So it's not like with ADSL where you can go and say, well, I'm going to switch to this ISP because they'll offer these other services that I like. As far as ISPs in your area, DSL, there are DSL providers which you can go to who offer IPv6. One of the ones I talked to, their point of presence is in Seattle, even though they can resell ADSL in the Grand Rapids area. I'd end up taking a latency hit, which means the package would take a little bit longer to get from point A to point B. That's not what I want to do.
Okay, so I guess my question more is, can I drop my V6 or V4 purchased static and get a V6 from somebody else? I mean, is it possible to like route that way?
Sure.
They have to be able to provide you service.
Well,
You'd want to keep your 4 address until everybody's using the 6, because otherwise you're going to have a lot of people not able to access your server.
There's kind of a chicken and egg problem right now.
and
Websites don't want to use V4 because nobody has V6 service, and nobody wants to provide V6 service because, hey, there's no V6, nobody using the V6 address space.
You do have options. What we're talking about now is the problem of transition.
Mm-hmm.
How do you transition to going from V4 only to both, and ultimately, to V6 only? It's actually really hard to become an ISP right now because there are no more addresses available.
Right. I think the government mandating everything be accessible by V6 is going to spur it on, because that will put government employees in the position of telling their ISPs, hey, I need V6 service, and if you don't provide it to me, I'm not going to contact